So today, this tool, this device has been used across the entire industry, and it has taken everything by storm over the last 5 years. This device has been around since the 18th century, but it's changed, and over the last year, it's become actually useful to the majority. What is it that I'm talking about? 3D printing. So 3D printers like this, or maybe like this, have came a long way. And I want to talk about those and how the metal finishing industry, the fabrication industry, the paint industry has really started using these devices over the years. And I think over the next 2 years, it's just going to be another mainstream item. So first, in order to understand why 3D printing is really awesome for the industry, for manufacturing, for fabrication and stuff like that, we have to look all the way back of how we used to use it in the 18th century. So we used to use thermosetting plastics like for tools like this. And, back in the day, they had rocks and things like that were very sharp. And in order to make the tools usable for the hand, they had to find a way of using a thermoplastic or tar or things of that nature to actually use the tool daily. So why am I really excited about this? I have a background in design, and I like using CAD. A lot of you think CAD is the most complicated thing in the world, but I can tell you right now, programs like Fusion 360 have came a long way and make it very user-friendly. So anybody could really jump on and within 30 minutes be designing. So years and years ago, when I started powder coating, we had a few different industrial customers that required areas of their parts to be free of powder. And typically we would take the good old micro attachments that I know everybody on here has seen, that ShopVac makes, and I believe they still have the patent on, but it's expired. And they would make these items here, and we would use them, put rags on them, and vacuum out certain areas of parts. Or we would even do the reverse and take things like this and blow out orifices or areas that needed to be free of powder. Now we have the ability to design to the part, which means you can take a $300 Bamboo Lab A1, and I don't know if that's the price, I believe that's what they are about, and take some TPU and design your own fittings, your own vacuum attachments. You can even design your own compressor attachments, different ways of blowing parts out. And I think it's important to stop here for a second, because I know there's a lot of stuff that goes into this and it might discourage a lot of guys, but TPU is a rubberized 3D print filament. And there's many different styles, different brands. A lot of them have different tensions. There's more malleable ones than others. I myself have printed off a bunch of these of a bunch of different styles to figure out which style and which one is the best. And there's also products like PETG, which is like a really durable, maybe not as pretty or aesthetically pleasing. And then there's PLA, which PLA is what 99% of everybody uses. And then you got like injection molded. So there's differences. Injection molded is obviously a mold that's compressed and yada, yada, yada. In order to help you guys and hopefully expand your fabrication business, your metal finishing, or just, give back to my community of coders, I know we all do powder coating, but it's awesome to see everybody in the group being so meshed together. And if somebody has a problem, giving them actual useful, helpful, even though they might be our neighbor, you're still helping them, and I appreciate that. So I'm helping you today. So we've got our Bamboo Labs 3D printer over here, and I'm going to just go through a simple CAD design, and we're going to throw it on the printer and print it off. Okay, guys, so in Fusion 360, it's free, by the way, for individual use. The main thing you'll use is Create Sketch up here. So once you have Create Sketch selected, you can go right into your axes. So we'll go to this base plate here. So it's just the overhead view. So we're in 2D right now, and you have shapes up here. Let's just simply do starting at the center point, I have mine set to inches, so you have 0.5, 1, 1.5. Let's just do a let's do a 1 inch by, and you also have here and here, so you can do 1 inch by, let's just do 1 by 1. So we'll go here and here, so you got 1 by 1. You can also type it in, so you could go 1 and then tab 1 and then hit enter, and there you go. So you have your first square. Now we're gonna make this into 3D by clicking solid up top right here, and then you'll click this extrude, and then we will bring it up to however big we want. We're just gonna do by 1. So 1 by 1 by 1, we've made a cube. And now if we wanted to put, let's say, a hole through this cube, you're just gonna go right back up to the sketch. Don't go to the hole here. It says hole. You could use that, but let's not use that. We're gonna go to create sketch, and we're gonna select this side of the cube right here. You see how it highlights? Click that. And now we're gonna put a hole. Start point is the center, so right in the center of the cube, we're gonna go and we're gonna just make it 0.5 and then hit enter. Now we have a drawing on top of our cube, or on the side of our cube, that is 0.5. Now we can go back up to solid, because we're gonna turn that into a 3D. So we're gonna go back up to extrude, and you can click on this before or after you hit extrude, and you're gonna go in or out. So you could bring it out and hit enter, and now as you can see, you have a, I don't even know what you want to call that, but a figure, a hammer maybe. So when you print this on a 3D printer, it's gonna suggest you put supports all through here because this is off the ground, as you can see. But let's go and reduce this back down. So we're gonna hit extrude, grab here on the end, and we're gonna put a hole through it. So we're just gonna go all the way back through, and now we have a hole, as you can see. So it's obviously got a lot more features than that, but this is the general idea of how easy it is to use something like this. Now, stuff like this can also be used to create dies. I mean, all kinds of cool stuff in the industry, even, like I was saying, a custom shelf. But now, let's go ahead and print that. So after exporting as an STL file, you open it up in, we're using Bamboo Lab because we have a Bamboo Lab printer. So whatever software your printer comes with, and it already recognizes it. So you can see here's our cube, 1 by 1 by 1. So now we're gonna slice it, which is right up here. We'll slice, and you can see some of this blue up top is a little bit of an overhang. Now the printer I have is pretty amazing, but some like my FL Sun would cause, it would need supports all through here because it would just basically melt it and it'd be a big glob here. So we're gonna see how the Bamboo Lab X1C prints this by just simply sending it to print. Now we have our X1C loaded up. So I just named the file that, but it's going to take 20 minutes, and almost half that time will just be it calibrating. But right now it's heating up the bed, then it's going to clean the nozzle, it's going to auto level, it's going to calibrate, and then it will print this. And the print itself will probably take, I mean, these prints don't take very long. I'd say probably 7 minutes. So we will let it go. Alright guys, so here we are. This is the print completed. As you can see, the top inner diameter there has a little bit of a, I want to call it like a straggle behind. So it's not going to be a perfect tolerance, but you could add supports in there for that. But as you can see, everything else is really, really good. So this is a PLA filament that has a silver flake in it. So there's a lot of customization, but this is very hard as to where these are not. So you can see these are squishy. So I hope some of you guys find this video helpful. If you guys have questions, please comment on the video. If you like this video, please remember to hit like and subscribe. Thanks.